Welcome to another lecture of NumPy. And today we are actually discussing about that, transposing the array. Okay, it's not transportation like from carrying one array to another. No, it's not like that. We are transferring arrays. Okay, so first of all, I have imported my NumPy library as we imported, and let's start. Okay, so first of all, I will create an array, arr. We'll assign a variable, then we will create a number. Okay, we will create a array of 15. Okay, a range 15, so we'll get a number from 0 to 14. Okay, but its length will be 15. Okay, now let's print it. Now we have got a array in which we have 15 elements, but it is counting from 0 to 14. Okay, got it? Clear? Now what we want actually is that first of all, we will reshape this array. Okay, we will reshape this array. And what does we mean by reshaping it? Okay, reshaping is nothing but we will transfer it. Okay, it is actually in 1D. Okay, it is actually in one dimension because we have only one axis here. We have only row. We will convert it into row and column. Okay, it will have 15 element already. Okay, if it is has 15 element, it will have actually 15 elements. Okay, so what I'm doing, see, we'll use reshape and we will pass a tuple in which we will say 3 5. Okay, what is this 3 and 5? 3 and 5 means 3 rows and 5 columns. Okay, 3 rows and 5 columns. Now you can see that we have 3 rows, 1 2 and 3. Okay, this one 3. We have 3 rows and 5 columns, 1 2 3 4 5, each have 5 columns. Now what we did actually that we had already 15 elements. Now we changed its shape from 1D to 2D. Okay, if we check the shape of it, okay, it is actually it is not, it is actually in the real shape of it. But if you check this shape, then it is 2 dimension. Okay, it's if you check its dimension, that is 2D. What does we mean by 2D? It has row and columns. It has x-axis and y-axis. Okay, now we have to keep one thing in mind over that: the total number. Okay, their multiple. Okay, the size of this matrix. This is actually a matrix. It is array. It is actually array, but it is actually a matrix. If you could see. Okay, the size of the matrix, okay, should be equal to the total number of elements. See, here we have 15 elements. Now if we multiply 3 into 5, we would have still 15 elements. Okay, now there can be other combinations can be made also, like if we use again the reshape, then we could pass 5 and 3. Okay, and it now we have 5 rows and 3 columns. Okay, 1 2 3, 3 columns. You could see 3 columns, 1 2 3, and 5 rows, 1 2 3 4 and 5. Okay, so we have 5 rows and 3 columns. Okay, now we have reshaped this, and this is actually we used in the many data in which we have data in only single row, and we want to convert um, into a tabular form. Are you getting it? Like, and if you want to get the data in the tabular form as we see in the Excel and all that, how do we use it here? Okay, we use reshape. Now there can be another combinations also. Okay, remember that the multiple should be 15. It cannot be at any other number. The multiple should be 15, and it should be an integer actually. Okay, it should be, man. It should be an integer actually, because how would you use float? Because if you, yeah, I know that you could use a float also, but you cannot make actually uh, a row in a 1.5. Okay, got it. You cannot make it. You're getting what I'm trying to say, that you cannot have a row. You can have one row, but you cannot have a 1.5 row, like one row and a half row. How you can it? You cannot. Okay, so let's be practical. Don't be egoistic that how we cannot do it. Yes, if it is, it is. Okay, now we again will do it. We'll use, why the hell my keyboard? Yeah, 1 by 15, 115. So 1 into 15 will get the same output. Now we will again do it with its reshape 15 into 1, in which we will have 15 rows and 1 column. Here we had 1 row and 15 columns. Now we have 15 rows and 1 column. You got it? Yeah. Now we have something that is actually very important. is transportation. Now transportation is transposing the arrays. Okay, what? Transposing the array. Okay, and not array but transposing the matrix. So what the transportation transposing, not transportation, why? Okay, so what does the transportation transposing, man, if I get wrong, understand it, what I'm trying to say. I'm making some mistake, but yeah, transposing. So transposing is but nothing but changing or converting rows to columns and columns to rows. Okay, I did you got it? No. We'll do example. Now what we are doing here is we'll create another array 2, and we will assign a array. Okay, inside we will assign array, and which we will make a 2D 1 2 3 1 2. Okay, 2D matrix. Now 3 4 5, then again 6 7 and 8. Okay, if we print array 2, then it is actually showing a matrix. Okay, now what we are actually trying to do here is that we trying to do that this row should come here. Okay, in the place of 0 3 6, what should we have is 0 1 2. Okay, we are actually converting all the rows to columns and all the column to the row. Now if I do dot t, okay, what does dot t means? Transposing. Okay, now you could say that we in the first row we had 0 1 2, and in the first row we have 0 3 6. Okay, now it was actually a column, now it has become a row. Okay, it was actually a column, now it has become a row, and all the rows has been become column, and all the columns has been become row. Okay, as you can see, this this this. Okay, those are actually columns. So this is what transposing means. Okay, now if we know the transposing of arrays, then we can actually use something, matrix multiplication, matrix addition, and all the things. We can do it. Okay, if we want to do the same. So what happened here actually is, wait, if I say, yeah, so here we have our matrix, which I haven't put elements in it, but let's put elements in it. Why the hell it's so old actually? Wait, let me erase it. Yeah, yeah. So let me give it number first. 1 2 3 4 5 6 7 8. Remind my writing, 8 actually, 8 and 9. Okay, this is actually a matrix. Now it is a 3 by 3 matrix. 3 by 3 matrix because it has 3 rows. Okay, understand it, and it is 3 columns. Okay, this is we use for columns, and this is we use for rows. Okay, we have 3 rows, 1 2 3, and 3 columns, 1 2 3. Okay, now if we want to perform the matrix multiplication, then we should keep one thing in our mind, that for doing the matrix multiplication, then we have two matrices, the first and the second one. Now for the second one, okay, suppose we have n into m columns. Okay, n into m columns. Okay, now if we want to multiply with the second column, then I should write it, then the columns, okay, the rows of second matrix must be equal to the column of first matrix. Okay, did you get it? So what I'm trying to say is that if we want to actually do the matrix multiplication, then the number of rows for the first matrix should be equal to the number of number of column for the first matrix. Okay, number of column for the first matrix should be equal to the rows of the number of rows of second matrix. Okay, now let me keep this aside. Let me select this all and keep this here. Wait, you should also. Okay, I'll do this here. Now we will create another matrix like this. And now what I have said actually earlier, that it is 3 into 3. And what is the condition for doing the matrix multiplication? Nothing but the number of row should be equal to the rows. So it doesn't matter with the column. Column should be 1. Actually, if it is 0 column, then how it could be a matrix? Column should be 1. But this and this number should match the number of column of the first matrix and the number of rows for the second matrix. This, if this two matches, then we could perform our matrix multiplication. Now let me create our lovely matrix, and we will do 1 2 3. Now how will we do it? So we will pick our we will pick our first, this first row, and we will multiply with our first column. With this we'll multiply it. And how will we multiply it? Element was element, with this, with this, and with this. Okay, we will multiply this with this with this, and this with this, and then we will sum it all up. Okay, 1 into 1 plus 2 into 2, okay, plus 3 into 3. Okay, it is 3 into 3. And what it will be? It will be nothing but 1 1 4 and 9, and it will be 14 actually. Okay, same wise for the another, we will do this, and that's how we will perform our matrix multiplication. Now the matrix, how will this look actually? Okay, so the resultant matrix will be the uh, will be the what I will say, will be the product of, sorry, actually the product of row of the first matrix and the column of the first matrix. Okay, row of the first matrix and the column of the second matrix. Okay, what we will do here is that this and okay, so as I said, the resultant matrix will be like this, where we have three rows and one column. We have one column and three rows. Now as I've said, for the multiplication this should be equal. Okay, and for the result, their product will be the result. Okay, 3 into 1. What is 3? 1, 3 is row and 1 is column. Okay, got it. Now let's code and we actually see how does the matrix multiplication do. Now in the NumPy we don't use matrix multiplication. We have something known as dot product. Okay, and the dot product. Now what we will do actually is that we have our arrays. Okay, we have our arrays. Now if we do array 2, okay, into array 2, what we will have, let's see. We had this. Okay, so what happened actually, that for the array 2 it got multiplied. Okay, if I could copy this, let me show you. And come on, yeah. So what happened actually, yeah, I could wait. Yeah, so what happened here is, oh my god, yes. So we had, so it's our first case. Okay, it's our first case. Now what happened actually here is that, as I said, we will do the matrix multiplication. Now we have 3 into 3. This is 3 into 3, and this is actually 3 into 3. Okay, now what we will do, we will pick the first row of the first matrix and the first column of the second matrix, and we will multiply element by element wise each of them. Okay, with this, and the result of them, okay, we will do first with this, then again with this, then again with this. Okay, with the first row we will multiply over 3 columns. then the resultant will be something this. Okay, there will be something, I'm not doing it, there will be something which is actually here 15, 18, 21. Okay, it happened like this. Now what we are doing actually, we are doing dot product, but if we do the transpose of the first matrix and we don't do the transport of second matrix, what will happen? We like got some different result. Why? Because it got transposed. Okay, it got transposed. And what is the transposed matrix looks like? Wait, it is not the transposed matrix. um yeah, this is actually our, okay, yeah, forget it. If the main thing is concept, I did some mistake, but it should be there, but actually understand it. Okay, are you getting it? That's okay. Okay, so what we did actually is that we transposed it. Okay, and if we actually do transpose of transpose, what I'm saying is that transpose of transpose, we did transpose and we did again our transpose, it will again will be the same. Okay, it will again will be the same. Now I'm doing this. Now what happened actually here is, yeah, now we had these two matrix and we had to do the dot product for them. We had to do the dot product for them. Now what happened? We picked we picked the first row of our first matrix and the first column of the second matrix, and we did the element wise multiplication. Okay, for this for this also, and that's how we got our this. Okay, now we have got what is matrix multiplication. Now we have some another techniques that how we can do this also. So we have first is that if we want to do the matrix multiplication, then we can use this also at the rate. Okay, and we could do this, we'll get the same output. No, wait, what, I'm doing something wrong or what? I think I need to got to search about this, what is the this actually. Wait, uh let me search it. Let me do this. Go to the GPT. Let me go to the GPT and let me ask it. So if you do this, then what will happen? Okay, the Python you can compare this. Okay, you could see what we are doing here is actually is that, yeah, it should be come like this. Why I'm not getting it? It should come like this, man. Why it's not? Wait, am I doing something wrong about? Oh wait, yeah, man, I am also, it should be, yeah, what, man, I am. What I did actually, that I used the array, the previous array. What I used actually this array, this one, which is actually containing the only one dimension. And if you are using one dimension to one dimension, then actually will be one dimension. So I did not use actually the second array, so we had to use the second array. My mistake. Okay. So this is how we can do this, and this is, and we have another technique also, in which we can change our accesses, in which we will use swap access, and we will use 0 and 1. Now 0 is used for the rows and 1 is used for the columns. Okay, 0 is for the rows. Okay, if I go and tell you, then 0 is actually used for referring the yes, 0 is actually referring for the rows and 1 for the columns. Okay, 1 for the columns. Now I hope that you won't be having any doubt. If you have any doubt, ask me in the comment, and you could also join our Discord. It is, you'll find many AI enthusiasts there also. And thanks for watching till now, guys, and bye bye. I will meet you in the next video. Bye, have a great day.